All right, let's dive into one of the biggest questions in all of tech right now. How do we actually know if an AI is smart or safe or even useful? It's a lot more complicated than you might think. We're asking these AI models to do incredible things: write our emails, create art, even code software. But that brings up a really simple question. How do we grade their homework? It's not like we can just pull out a red pen and mark things right or wrong. So, what's the real report card for an AI look like? Well, the way we grade AIs has totally transformed over the years. Our tests have had to evolve just as fast as the technology itself, and believe me, that's moving at lightning speed. To put it simply, we've gone from tests that were basically just simple keyword matching to now having to design exams that test an AI's ability to solve really complex, real-world problems. I mean, it makes sense, right? You wouldn't give a PhD candidate a first-grade spelling test and expect to learn anything meaningful. So, to really get where we are today, we've got to look back at the journey of how we test AI. It's a fascinating story that takes us from simple, rigid rules all the way to trying to measure abstract reasoning. You can really break this down into four distinct eras. Way back before the 90s, everything was rule-based. Super simple stuff like, if you see the word hello, respond with hi. It worked, but it was incredibly brittle. Then came the statistical era, which brought in probabilities, a huge step up. But the real revolution kicked off in the 2010s with the neural benchmark era. This is when we started getting sophisticated tests like GLUE, which stands for General Language Understanding Evaluation. The whole point was to see if models could actually understand language, not just spot patterns. And today, well, we're in the agentic era, and it is a completely different ballgame. For a long, long time, our main tools were these metrics with names like blue and rouge. Honestly, you can just think of them as really fancy word counters. All they did was check for how many words in the AI's answer overlapped with a pre-written correct answer. See the problem? You could have a brilliant, creative, and 100% accurate summary that gets a terrible score just because it didn't use the exact same words. The whole system actually punished creativity and couldn't tell you if the AI understood anything at all. And this is where everything changed. As models like GPT got bigger and bigger, they became these massive vaults of knowledge. So counting words was obviously not going to cut it anymore. We needed tests that could probe that deep knowledge. That's what gave us benchmarks like MMLU, the Massive Multitask Language Understanding Test. This thing is a beast. It's basically a giant final exam covering 57 different subjects, everything from professional law and medicine to high school physics. The goal was no longer just about testing language. It was about testing a model's understanding of the world. Okay, but think about it. How could you possibly grade millions of these incredibly complex MMLU-style exams by hand? It would be impossibly slow and cost a fortune. So, the AI community came up with a solution that sounds like it's straight out of a sci-fi movie. What if we get one really smart AI to grade another one? So here's the trade-off. Humans, we're amazing at picking up on nuance, sarcasm, and subtle context, but we're also slow, we're expensive, and let's be honest, two different human graders might give two different scores. A powerful AI judge, on the other hand, is the complete opposite. It's blazingly fast, super cheap, and it's perfectly consistent every single time. This LLM as a judge idea was the key that unlocked our ability to evaluate models at the insane scale we need to today. For a while, the gold standard for an AI judge has been GPT-4. It agrees with human graders more than 80% of the time, which is pretty amazing. The problem? It's a closed-source black box. We can't actually see how it's making its grading decisions, and that's exactly why the development of open-source models like Prometheus 2 is so important. This is a model that was built from the ground up just for evaluation. It gives researchers a transparent and affordable option, which is absolutely critical when you need to trust your grader. But as you'd expect, as our tests get smarter, the problems get more complicated. Now we're dealing with new challenges, like AIs that might be cheating on their tests, hidden safety risks, and a pretty big gap between how a model scores in a lab versus how it performs in the real world. Okay, this is a massive issue called benchmark data contamination. Since these models are trained on basically the entire internet, there's a really good chance they've already seen the test questions and the answers somewhere in their training data. So when it spits out the right answer, is it actually reasoning and figuring it out, or did it just memorize the answer key? It's the difference between actually knowing calculus and just having the solutions manual to the textbook. And this all leads to a major disconnect. In the academic world, the main goal is often to get the highest score and climb to the top of a public leaderboard.
But if you're a business trying to use this stuff, that high score means nothing if the model isn't also reliable, cheap, fast, and, most importantly, safe. A model can be number one on a benchmark and still be totally useless for a real product if it makes up facts or has serious safety flaws.
So how do you find those dangerous, real-world flaws before your users do? Well, you have to attack the system yourself. You have to try and break it on purpose. This whole process is called red teaming, and it's basically an adversarial approach where experts poke and prod the AI to find its weakest points and hidden safety vulnerabilities. And these red teams have gotten incredibly clever. It's not as simple as just asking a direct, harmful question anymore. They use all sorts of tricks, like telling the AI to roleplay as a fictional character who doesn't have any safety rules. Or they might hide a malicious instruction deep inside a long, innocent-sounding story. They even use slang or bits of code to try and sneak past the AI's built-in safety filters.
And all of this brings us right to the very edge of what's next. So far, we've mostly been talking about testing an AI that gives you answers. But what happens when the AI stops just talking and starts taking action?
That's right. We are now officially in the era of AI agents. These aren't just chatbots anymore. These are systems that do things. They can use tools on your computer. They can browse the web. They can write and execute code. They can handle complex, multi-step projects all by themselves. And trying to figure out if they're doing a good job, well, that's a whole new world of challenges.
Yeah, grading an agent is way more complex than just checking some text. The questions we have to ask are totally different. Did it actually finish the job it was supposed to do? Did it use its tools correctly, or did it, try to use a calculator to write an email? Did it remember a key piece of information from step 1 when it got all the way to step 5? And maybe the most important question of all, did it stay in its lane and not do things it was never supposed to?
So for anyone out there who's actually building with this technology, the way forward is to build a solid evaluation framework. It's a continuous loop. First, you define your real business goals. What does success actually look like for you? Second, you build a golden data set of test cases based on how real people will use your product. Third, you pick the right metrics and tools for your specific job, whether it's coding, retrieval, or whatever. And finally, and this is key, you build that evaluation loop right into your development process. It's a new paradigm called eval-driven development. And what's the ultimate goal of all this? It's something the researchers are calling trustworthy productivity. The idea isn't just to build more powerful AI. The goal is to build AI that is provably reliable and safe because it's being tested constantly, rigorously, and automatically. Which leaves us with the big, final question for the future. As AI shifts from being a passive tool that just gives us answers to being an active agent that takes actions in our digital and physical worlds, our tests have to evolve once more. We're not just in the business of measuring intelligence anymore. Now, we're in the business of measuring trust. And that right there is going to be the defining challenge for the entire next era of AI.